Don't share screens.
You're live.
Okay, so today we're going to be going over custom configurations, and this is session 14, technical session 14. And we're going to be talking about different type of configurations that you might need to build for your clients, for your employer, or for yourself. So let's get into it. So our objectives for today is A, to describe different custom configurations to meet common client needs. B, or two, to describe the features and characteristics for the different custom configured workstations. And last, to given a scenario to select the appropriate components for a custom PC to meet the specifications of a customer or their needs. Here we go. All right, our BSMs to keep in mind today are communication. You want to have good and clear communication between the interested parties, whoever is asking you for these projects, right? And then the second one is growth mindset. We always want to keep a growth mindset. We always want to be better tomorrow than we are today, and we want to apply that to our work, always. All right, let's get started here, folks. All right, so specialized custom PCs. So there's going to be a lot of times when we need specialized computers, right? Who has ever heard of a home theater PC? You guys can raise your hands or whatever, you know. Have you guys ever heard of a home theater PC or a home server, maybe a home data server, right? A gaming PC, I should see everyone's hand pretty much go up. A typical workstation. Okay, who has been to a restaurant where they have POSs to like put in your order and stuff like that? Okay. Who has heard of a print server? All right. So all these things are different. They're all PCs. They're all personal computers in some way, right? And they're all different builds. Okay, and some of them may be workstation, like things that you do for a job, in a professional environment. Other things might be for personal enjoyment, like a gaming PC or a home theater PC or home server PC, right? But the point is that they're specialized in a certain way. They're built to do a specific task, right? So we're going to be talking about all of these, right? And three of the most common are stated here, which is the workstation PCs. These are like your everyday run-of-the-mill. They need to run office jobs, right? They need to be able to run Excel. They need to be able to connect to the network. They need basic standard functionalities, right? You have media workstations. These are a little bit more specialized. They typically have some components that are higher end. Like, let's say if you work in graphics, you probably need a better graphics display. You probably need specialized displays themselves because you need to be able to differentiate between colors, right? And then you might have, if you have your own business or you work for a small mom and pop shop or something like that, you might need to build PCs for consumers who come in, right? They might have very specific needs and they need those things built out for them. So we're going to go into in depth about all of these, and we're going to talk about all of them a little bit more. So the first one is the thick client, and I was thinking of a corny joke to say, but I'll just keep it to myself. So a thick client is a PC that has all the capabilities of a standard PC. It runs a modern operating system and general productivity applications to accomplish the majority of tasks needed by home office and home users. The key to a good thick client is sufficient core hardware to support the OS and typical desktop applications, such as office productivity and network applications. All right. Who can, does anyone have an idea of what a thick client is? Like, in their own words? Like, if I told you, hey, I need you to pick up a thick client, how do you think you could do that?
Use proper back support.
All right. So another way to think about it is that thick client is pretty much almost off the shelf, right? Like you go into, let's say you're going into Best Buy and you're just picking up a regular run of the mill middle of the pack PC. That is usually a thick client. There's very small customization to it, and what sticks out about it is that it can do a little bit of everything, right? It has network capabilities. It can run a modern OS. So probably in today's day, it can run Windows 10 or the newer Mac, but it's not highly specialized. It doesn't have a crazy GPU unit. It doesn't have a crazy amount of storage. It's just is giving you what you need, right? It's giving you a little bit above the bare bones, just a little bit above, right? So that's a good way to think of a thick client. And most of your computers in a corporate setting are going to be thick clients. Like, you're unless you're working at like a design place or like where your users need high end components. Most of their computers are going to be regular old thick clients, things that connect to the network and that give them the opportunity and the availability to run regular applications.
So would it be like a basic computer, pretty much like a jack of all trades?
Yeah, exactly. That's a good way to say it.
Okay.
Yes. Yeah. This is the term that they'll use though, the client. So let's keep that in mind. And you'll see that there's going to be a different kind of client that is definitely the opposite of that. Oh, it's the next slide, thin client. So let me have a little help from you guys. Let me pick on my girl Crystal. Read this slide for us, Crystal.
Hello, thin client. A thin client is a system designed to outsource much of its work. These PCs have just enough hardware and power to run the selected operating system and a few basic applications. Thin clients usually rely on resources from powerful servers, so they may not have hard drives or store any data. They serve as single-purpose systems like point-of-sales machines. The only requirements for thin clients are network connectivity and access to servers over those networks.
All right, awesome. So a thin client is almost the opposite of a thick client, right? The thick client needs a little bit of everything in order to serve its purpose, right? It needs to be able to store some data. It needs to be able to connect to the network. It needs to be able to run applications on it. Thin clients basically just need to have a NIC card, right? They need to be able to connect to the network and access the servers on those networks, right? Because all those applications that are being run on the thin clients are actually in the cloud. They're being pulled off of a client. Okay. So thin clients, you'll see a lot of them in retail. Actually in retail now, when I go to like I was at Lids a month ago or something like that, and they don't even have terminals anymore. They run them on handheld devices now, right? And basically, those handheld devices are thin clients because all it's doing is connecting to the network over the air over their Wi-Fi, and that's how they run their retail operations now. I'm sure not all retail stores are like that, but for the most part, they're trying to go in less physical hardware at the location. Okay, I see a lot of hands up. All right, let's start with Steven.
Here's another thing is they're also trying to go for less inventory. So basically what it is people don't like ordering things like clothing online because you don't know if it's going to fit you, right? Everybody has different body types, and the size depends on the company and all that fun stuff. So what they'll do is they'll have basically you go into the store, you try on the sizes you like, but they only have one of each kind. And then you can order online based upon your size profile at that point.
Yeah. That's a good point, Kelly. Yeah. Awesome.
So I just wanted to mention, when I was working retail like years ago, we had a mobile POS system. So is that technically a thin client?
Yes.
Okay. Just wanted to refresh my memory on that. Got you.
If you'll notice, I don't know if you ever had the displeasure of working when the server went down. If your server goes down, you can't do anything.
Oh
And
yeah,
why is
yeah,
that? Because everything is getting pulled off of those servers,
yeah. I've been there. Yep.
right? So we had when I used to do restaurants, our servers went down and we couldn't do anything. We couldn't process payments. We couldn't even log on. Our system could be because even the operating system isn't on the thin client; it's on the server. So what that thin client is doing is connecting through the network to the servers and pulling those virtual machines, the operating system, all of that off of the servers, and that's how these things work. Bubble car.
So it's basically a machine with only a processor with no storage, right?
Yes, no storage. It's mostly it's pretty much just network capabilities and
Yeah, just
peripherals.
a processor.
You need to be able to connect your peripherals, whether it's a touch screen, whether it might be a keyboard and mouse for some clients, because it like you might be like, oh, but there's a monitor, there's a mouse, like that those are just the peripherals, right? That doesn't make it a thick client or not. What makes it thick or thin is its internal capabilities. It's the processing, the RAM, all those, the storage, right? It doesn't have any of these. It to be a thin client, it pretty much just needs to be able to connect to the network. And another term before I go to DeWitt, because I see your hand up as well. Another way that you're going to hear these called are dumb terminals. So if you hear the term dumb terminal, thin client, you should be thinking just network card, network capabilities. That's about it. Okay, DeWitt, what's up?
My question is why not they use regular computers with high processing capacity? When I see always they use large network cables and they didn't use even modern computers. I don't know why they use like this.
Okay, so think about if you're in a place with high demand, like or with a lot of people want control. Companies want control over their data and their resources, right? They want as much control as possible. So the way that these things are, the way you get most of that control is by physically having the control to it. So most of their important data and a lot of the resources that they need, they'll have it on a central server, and that server is able to spin up those instances and send it out to the thin clients as they request them, right? So those resources are in a central location, and then as each thin client needs it, they'll be able to pull off. Some of these things are still they may be expensive, right? The server is probably the most expensive thing, but the thin clients itself, it just makes it easier to keep track of, to maintain. It has lower pricing for everything. If you got to put an expensive terminal at every station, those kind of things start adding up because you're still going to need the server as well. So they try to make the clients as inexpensive, right, and as least complicated as possible, and just have them connect to the main server. If that makes sense. That's why you probably won't see these high-end
Also,
processors.
from a security standpoint, if somebody grabs a terminal and walks out, you don't lose proprietary data.
Right. That's what I was trying to say with they want to keep control over their data and those trade secrets. Brianna, what's up?
Okay. I just wanted to clarify. So the thick client does anything you need it to do, or at least most things that you would need it to do. But a thin client is the bare minimum of what the company would need.
No, the thin client isn't even the thin client just connects to the network. Just connects to the network, and then it pulls those resources from the network. The thin client itself. So if you see here, because this is what they'll ask you, like there is this system only connects to the network. What kind of system is it? And you need to figure out that is a thin client. So they usually serve single purposes. So like they might be a point of sale system, which is POS, right? We see those in retails. Sometimes they may be like server states, like how we've been to places where you do like surveys on a what do we call those, kiosks? Kiosks are considered dumb terminals because they're usually just a device that's connected over the network and pulls all its information and resources off the network.
Okay, and the thick client is it it doesn't just connect to the network, it kind of does everything?
A thick client will have storage on it. It will have RAM, and it will have its own processing abilities. It could run a standard OS. A thick
Okay.
client. Yes. So a thick client, think it could do a little bit of everything. Like it's what you need to do a little bit of everything. It's not highly specialized, but it can do all those things. Yes.
Okay. Thank
All
you.
right. Sure. Ume.
Yeah, I want to clarify too, like the printer, those are thin client.
A printer is its own thing. We're talking about workstations. We're talking about we're talking about the computer system itself. A printer is a printer is a printer. A printer may be connected to a server.
Yeah,
And
because yeah, so yeah, it is connected to a server, and
Yeah, some printers may be connected to a server. Some printers may not. It depends on where you're at. It might also just be connected to a different computer that is set up as a server. It depends, really. We'll talk
depends, I
about
understand. Okay, all right.
we'll talk about printers when we get. Trust me, we have a whole couple days on printers.
Okay, but the only thing is, if you ask before in the quiz, there's the problem because, you know.
Well, some questions might arise, but we'll teach you about it. But right now, so the thin client and the thick client is not about a printer. So yeah, we're not there yet. Yeah, what's up, Francis?
So just to try to clarify, a thin client would be like if you have a Fire Stick, you're calling to the Netflix server to be able to access that movie. A thick client would be if you had a bunch of CDs and you download those CDs to your hard drive, and that's where you always access that information. It stores, it's more capable. Think of a thin client as connecting to a service. It's just the apparatus you would use to get there.
Exactly, and yeah, perfect. And the way that you connect to those things is that it has to have a network interface of some kind. Yes. Good job. Babacar, do you still have another question?
Yeah, just want to add on to what Francis is just saying. So the thin client is like a remote computer. So it doesn't have no storage or anything. It just works remotely through accessing other servers. And
well, your thick client can work remotely as well. But here's what I want you guys to remember. Kind of like what Francis kind of alluded to it just now. You can't. Your thin client will not have a hard drive. You will not be able to store stuff on your thin client. It won't have optical drives. It won't have those components. It's the one requirement of the thin client is for it to be able to connect to a network. It has to connect to the network. That's the thin client, because it pulls all its resources. Everything that is going to be done on that thin client is done over the network.
Over the network, that's right. And the thick client is basically the desktop computers that we all use.
A thick client can have a little bit. A thick client can have a little bit of everything. All right. Yeah. A thick client can have optical drives. A thick client will have hard drives. A thick client can have RAM. It'll have all those things. It could have a decent processor, a decent it might have a GPU. It might have an integrated GPU. Okay. Thick client is almost. You go to buy a basic PC at Best Buy. That's a thick client because you're buying it off the shelf. There's no customization to it. Think about it that way. And when you buy a PC, usually in the store, you expect it to do a little bit of everything, right? You expect to be able to run Windows on it. You expect to be able to download maybe Minecraft or something basic. Like a thick client will be able to do those kind of things. All right. Does that give you a little bit more clarification, Babacar?
Yeah, I understood. I was just trying to pinpoint, just to try to clarify a little bit, but I understand the difference between thin and thick. Thank you.
Right. No worries. All right. Okay, a virtualization workstation. So this is where things start getting a little bit more high tech, a little bit more complicated. We start seeing higher end components coming.
Excuse me, sorry, dog. I'm sorry. I'm sorry. I'm going to go back to thin. You said dumb, like D-U-M-B?
Yeah, dumb. We call them dumb clients. They don't.
All right, cool.
What did we say is the brain of a computer or a computer system? What did we say was the brain of it?
The CPU?
The CPU, right.
So they
right. So these things don't. They don't process information. They all their stuff gets pulled off a server.
Yeah, cool. Copy.
All right.
Thank you.
Processor essentially on it is minimal.
Yeah, it's enough. It's enough to get the network card to work, pretty much. Now,
Cool.
its network cards are really good. That's one thing you need. They usually have high end network cards, right? Because that's everything that runs on it, right? So they need to have those really nice network cards. So that's one thing to remember.
All right, cool.
All right. You have another question, Babacar? Okay. All right. Virtualization workstations. So and I apologize, guys. I have construction going on. I kind of warned you guys about this in the beginning of the cohort. It's never ending. But virtualization enables to run more than one operating system at a time in a single computer. A virtualization PC is called a host, while the VM stands for virtual machines. So virtual machines mean they're not physical, right? They exist logically inside of the host. Are you guys following me? Does that make sense? Does anyone need a little bit more explanation about this right now?
I do.
Okay. All right, who's that?
Me, Brianna.
All right. So, a virtual machine is a logical machine, meaning that it exists logically inside of the processor of the host machine. It's not a physical machine, right? A physical machine means it's right here. It's physically here. I can touch it, right? Right. But so for virtualization PCs, what happened is you have higher end processors, you have a lot more RAM. And what happens is this allows you to divvy up those resources and run multiple operating systems in there. So you might have one physical machine, but because the resources that are inside that machine are so great, you can divvy them up and then run lot more machines inside of them. It's kind of
but it's not a physical computer.
It's not another physical computer. So you'll hear us talking about, like I just alluded to this earlier when I was talking about thin clients and how they pull their operating systems off of servers, because there'll be these really high-end servers that their job is to spin up virtual machines and have them available to the thin clients to pull them off. So those machines exist inside of another machine. Let's put it that way. But I don't want you to think of them as like physical machines inside of the other one. It's just that they're being ran inside.
They're alternate personalities. That's how you can think about them.
Kind of, a little bit. Yeah, it's kind of an interesting way to look at it. I think you've been watching too much Split.
Nah,
okay, it's like Split. Got it.
Yeah.
Oh my God, did I really get it?
I got you.
All right, but yeah, so that's kind of one way to think about it. Go ahead, Francis. You got something to add here?
Yes, so just put it in the user's perspective. Let's start with, I have a Windows computer. If I wanted to...
I'm so sorry. I didn't get any of the beginning. Would you be able to start over for us?
It's okay. Got it. So let's start with it from the user's perspective. I have a Windows computer and I have 8 cores on that CPU. I'm going to then pull up a program that will allow me to host another computer within that Windows computer. Let's say that is a Macintosh. So I'm going to dedicate 4 of those CPU cores out of my 8 to run my Macintosh software. That's going to be a sample program would be VMware. Within that, I can then on another screen or window pull up my Macintosh computer while also operating my Windows computer. So it's like having 2 computers, but my Macintosh is exclusively virtual, and it is not the first computer. I have to pull up my Windows computer and then in my VMware pull up my Macintosh. I'm not sure if I explained that properly for people to get it, but it's essentially
a computer within a computer.
It's a yeah. So she did a really good job of explaining that. Yes.
Okay, so a Macintosh is like a
Francis even
Macintosh
mentioned
is a
that.
virtual PC, is it? Like it's in real life, it's a virtual PC.
No, she's giving you an example. So
Oh,
Macintosh
okay.
is the operating system for Apple PCs, right? So, but let's say I have right now I'm working on a Windows PC. I have a decent processor, like she said. I have 4 cores, right? It's not crazy, but I have 4 cores. I can split up my resources and use 2 of those cores to pull up a separate operating system, which could be, if I want, it could be an Apple operating system, or it could be a different Windows operating system. It doesn't have to be specifically Apple, right? Or it could be Linux. It could be whatever I want it to be. But the point is that I'm creating a separate machine that runs independently. It does all these other things independently inside of my machine. That machine exists inside of my laptop. My laptop didn't change in size. Everything's happening inside of it. What's happening is that those resources that I had, those 4 processors, are now being used to run these different instances of operating systems.
And they
Right.
are independent from each other, right?
My RAM gets shared too. What was that? I'm sorry.
And it's independent of the host.
It's independent, yes, but I still have to turn on my host computer
to access the guest.
Exists, but it does exist because of it. Yeah.
Okay.
Yeah, but I would be like, if I have 2 screens now, I would be able to run Windows on one, Macintosh on the other, maybe Kali on something else. I would be able to do that. Yeah.
Okay. Thanks, Francis. You've been saving me this morning.
Thank you, Francis. Kayla?
So to add more, just one little tidbit for a more practical view of people using systems like this is what you're saying, like cybersecurity, where if they found something and they don't want it to affect their main systems, they'll make like a second computer so that anything, if they open up the file that they don't know, it's going to affect that and they can just delete it. And then their main files, like their main computer is okay. So they'll use a lot in cybersecurity, like that method, so that like you don't get anything attached to you.
Yes, great point. It is used in cybersecurity. It's used to test too. Like if you're rolling out new software as well, if you're rolling out new software and you don't know how it's gonna act out, what you do is you get a server, you spin up maybe 20 or 30 virtual machines on it, and you test your software on these virtual machines, right? And that's how people do a lot of debugging, or that's how a lot of testing happens. So yeah, it's used in those applications, and cybersecurity is used in research and development. And it's also like I know I keep alluding to this, but it's also used because we got to remember that these things are called hosts, right? And it's used to serve this to the clients. And a client is a PC that is pulling information off of a server, and the server is the host because it's hosting those things. Does that make sense? Okay.
DW.
What's up? What's up, Adriel?
I'm gonna be very honest with you. I can break this down in a way that I can understand it, because I grew up around this kind of stuff already, so it's not too hard. But I was gonna say, I don't think everybody's gonna get. I wanted to say I don't think everybody's supposed to get this on the first try. This is gonna take a little bit of time before you guys understand it and you're confident. But the virtualization is literally just acting as if something else is there when nothing really is there. So I would say try your best to break it down into a form that you can understand instead of like the technical version of it, because maybe that will end up messing you up in the long run.
Definitely try to word it in your own ways, but also do understand what's happening inside. Yeah. So I get what you're saying, where there's nothing else in there, but there is something else in there inside that processor. Like there's a new operating. Like if you're running Windows and now you're able to run Mac on there, that exists inside of it. So I would be careful about how you kind of word that there. But essentially virtualization means it's not physically there. Like it's running inside of your system, and those processors, RAM, those resources are being used to do something that you wouldn't be able to do, or you would need a whole nother computer to run Mac, right? Usually that's what we think. Oh, I have a Windows, but I want to run Mac. I need to go out and buy a MacBook. When you could really, if you have the resources on your PC, you can spin up a virtual instance of Mac in it, right? And I see you guys up there. I just want to get through these last 2 bullet points real quick because it kind of ties into what I'm saying here. So some of the purposes for this is that it saves hardware costs when needing to access different operating systems, right? So if you have an office of 40 people and 30 of them need to run Windows, 5 of them need to run Mac, and another 5 need Linux, it might be more cost effective for you to run a server where some of these different operating systems can be spun up instead of going out and individually buying the hardware for all these different systems, right? And then like Kayla said, it allows for easier testing, and it's like I just said, it supports a lot of different working environments. George, what's up?
So my question is, so you know how like you can have different desktops on like Macs and PCs, like a completely different desktop than what you currently have on your computer. Is that a virtual machine, or is a virtual machine something that shares resources, like a completely different computer is sharing resources, like half of your resources on your computer, and another process going on, like another whole completely different computer technically sharing resources as well? Is that the caveat?
Okay.
Like you need to share resources?
So the resources are being shared, but when they're on your PC, so if you're like, when you're saying desktop, do you mean you have one Windows and then you have another Windows, or are you just talking about like a user desktop, like your user profile? Like
I was talking about like the Windows. You know how you can like I'm not sure what, I don't really play around with Windows too often, but I know on Mac it's called Spaces, and you can have a completely different desktop. Like you just kind of swipe and it's just 2 different desktops.
So for Mac, so you can do different operating systems in Mac, but we do it through a thing called Boot Camp.
Yeah.
So if you're using Boot Camp, then yeah, you're spinning up virtual machines. You're spinning up a Windows instance. And
okay, so the difference
those resources are being shared, and it's kind of the same thing in Windows. Go ahead, Francis.
The thing is, he's talking about Spaces, which is creating separate desktops. So if you wanted to have one, but no, it's different than Boot Camp and Parallels, because that's actually loading an OS. You're not loading an OS in Spaces. It's also called desktops in Google Chrome and Mac. So it's a little bit different. It's software organization, where you could say this one desktop, I'll be able to call up and switch between the 2 desktops for work, and then one will be for graphic editing, and another. It's slightly different. It's not really. It's more of a software thing, but not really. It's still using the same processing.
That was my question. So does it have to be shared hardware for it to be a virtual machine? Because you can sort of do the same thing software wise.
Well, even when you're running that, you're still sharing the thing. But what she's saying is you're not spinning up a different machine, because these VMs are virtual machines. Like that's what it stands for. It's like it's basically like you have. All right, let me give you a concrete example. I have eight cores. I have 12 gigabytes of RAM or whatever. Let's just make it up. And I want to split those up, right? Now, those virtual machines, let's say I allocated 6 cores to one and I allocated 2 to the other. So now that one virtual machine is using the processing core, the power of 2 processing cores for one, and the other one has the power of 6 in it, right? And however I divvied up the RAM for it too, that's how much resources they're given. So you do have to set specifics for it.
Okay, thank you. To answer my question, because I thought it had to do with hardware. Like you have to divvy up the hardware to, like, the RAM and stuff. To
you have to select how you're going to divvy those up. Yes,
that was my question. Thank you.
Absolutely.
We will have just a whole key session on virtualization, so we will get into a lot of this stuff again.
Yes. Ume.
Yeah. So AWS, Amazon Web Services, Amazon Cloud Computing? Does
Yes.
it process the same ID?
Yeah, Amazon Cloud Services, course, even in Coursera, those things are virtual machines where you're doing all that stuff. Yeah, those things are they're getting spun up in the cloud, and you're accessing them through that. Yes.
Okay.
Yes. This is like Adriel pointed out. This isn't something that we'll get on the first try, but it's good to start getting that image in your head, because sometimes we hear the word virtual a lot and we don't really understand kind of like what it means. But so what I want you to think about with virtual machines is that these are machines existing inside of another physical machine. Something is hosting them, and they're there, but they're inside of something else. They, just because a server has 30 different Windows machines on it doesn't mean that there's 30 different physical machines out there. They exist inside of it logically. We're gonna hear that. We're gonna hear that word a lot too. You probably heard it already with processors, right? We spoke about processors, and we heard it there about physical processors and logical processors. We spoke about processors, right, Kelly? Yes. Okay. Yeah. So logically means that it exists inside of it, like the system is viewing it as something. When physical means it's a physical thing that you could point to and touch. What's up, Galen?
So virtual machines, apps are virtual machines, right? Like if you go on your phone, you click on Facebook, like that's a virtual machine, right?
So Facebook is an app.
Like, no, I mean, like if you want to look at it like that, like if you want to give an example of it, it's like you hold your phone, right? And then you want to choose an app. You choose the app that you want to go to, right?
Mm-hmm.
Or am I way off?
Well, the app, like the Facebook app that you click on your phone, is software. It's a software. So it's not a virtual machine. A virtual machine is something that's going to be capable of running its own processes, like doing its own computations and using up your resources to do that.
Okay, I think I got one. DW. Jimmy Neutron right here, right? So when you think about going to YouTube, if you're going to YouTube, you're accessing YouTube through your computer by going through your browser. That browser is going to be what you would consider a client. That client accesses the server that is YouTube. YouTube in itself is contained on a bunch of computers that they have in their server. Every time you now try and get something, like try to find a video on that server, that is what you would consider the virtual machine, because you don't actually have that video on your computer. You are just trying to pull something from where they have it actually located. So the virtual machine, usually, like when we're talking about virtualization, is like, okay, I'm going to split up my resources in order to use one system in two different ways. So I could have half of my system allocated to Windows and half of my system allocated to Mac. So you can do two different things, or you could split up more if you wanted to. It's the same system, but you're using different parts of the system in order to do different things.
Got it.
Okay.
Did I get that, DW?
It's kind of, I wouldn't agree with YouTube. Here's why. YouTube is storing information, right? It's storing videos, it's storing all these things. And yes, it's a server. You're right that those things don't exist in your computer. You're pulling them off of the YouTube server, but you're not, like, if your computer doesn't have the processing power to pull those videos off, you're not going to be able to see it. So the virtual machines are allocating resources, processing power, RAM. We're going to, like, it's on this slide. RAM is really important for virtualization. Like, a virtual machine is something that is going to allow that virtual machine to make its own processes. Remember, processes is the calculation of data. It's able to perform its calculations. Everything that happens in our computers is math. It's brought down to math. So that's why I wouldn't agree with your YouTube analogy. Do you understand why I'm saying that, Adrian?
Yeah, I got you. I understand.
But you're right in the sense that YouTube is a host, right? It's hosting all of these videos for you. And then, yes, we go out there and we pull them off, and we're clients in that part. But virtualization is about being able to use resources to perform certain calculations, and usually we do that by spinning up operating systems, and that's why we call them operating virtual machines. But because these machines, when I spin up a new instance of a Windows machine, guess what? On that Windows machine, I can go run Word on it. I could go run PowerPoint on it. I could go run all these different things on it, right? If I'm spinning up a thing for Kali, I can go and run a bash terminal. It's literally like having that computer, but it's without physically having it. You know, like you have the capabilities to do what you want, but you don't have an extra machine for it because that machine exists inside of another machine.
This is crazy.
Does that help you understand it, Galen?
I get it. I get it.
This is
Hey guys, there's a lab on this on test out, and I feel like this would really clarify a lot of your questions. So
we also, how many of us have? Because I know
stole our thunder on that, Donnie.
How many? Some of us have done your Coursera stuff. Some of us has done Coursera.
Yes.
Right. We've done like the Linux labs. Has anyone gotten to those? Like the Linux or like or the Windows labs where you got to sign into Quickie Labs. You've done it.
I have.
So when you do that, George,
it,
that window that pops up for you is a virtual
machine. Yep.
Yeah, that's a virtual machine. That machine exists on Coursera's server, and when you log onto it, it gives you access to that machine, right? But all those things are being processed not in your PC. It's being processed on that server, right? And they have hundreds of those in whatever kind of server they're using. Galen, do you have another question, or is your hand just up, bro?
Sorry, it's just up. My fault.
All right. So now we're going to talk about the requirements for virtualization. George, can you read this for me, please? Thank you.
For good performance on a virtualization environment, a lot of RAM is required, and fast CPU with multiple cores is recommended. RAM is the most important requirement since each virtualization workstation needs enough memory to run a native OS, the guest OS, and any other applications running in either OS. If there is not enough memory, the VM will not start. A powerful 64-bit CPU with many cores also helps virtual machines to run smoothly.
All right. So when these questions pop up, they are not going to ask you about the theory behind it very much. Like for virtualization, you just need to know that those machines are happening inside of something else and that they're not physical. But what they are interested in is that you know the requirements and what you would need to build a good machine of that type. So for a virtualization machine, the highest requirement is RAM. So you need to be able to run with enough RAM for the native OS, which is the host OS, and all the other guest OSs. All right, and we haven't gone into how much RAM these things need yet. We haven't gone into that. We will later. But remember, RAM is the most important thing. If you don't have enough memory, you're not going to be able to start your virtual machine. And then the second most powerful thing, the second most important thing is going to be multiple cores CPU. Give me 1 second, Cynthia. I got you. I see you. Give me 1 second. So RAM is the most important, and then powerful CPU with multiple cores, because you need the different cores to be able to spin up all the OSs. You have a question, Cynthia?
I do, sorry, and I'm on the loud laptop because I'm using the other one for something else. So I have a question. You see what you just said, that when you do the labs and then you log into the Coursera and you have to troubleshoot something like that. So my question is, when you install those programs, are they getting on my laptop? Because I was a little bit worried. I thought I'm actually working on my laptop, but I realized that I was working on the Coursera screen. Thank you.
No. So those everything that you do on Coursera, you don't download anything. Everything that you're doing there, even on Test Out, everything that you do on Test Out is not downloaded. It's on the cloud. You're pulling all that off of their servers. So no, that what might be happening is that you might have a lot of network traffic, and maybe you have a lot of network traffic and it may be slow or something like that. But all those things are taking place in the cloud, which means it's taking place on their PCs, on their servers.
Thanks. I freaked out. I was like, oh my gosh, what am I downloading and uninstalling?
You shouldn't be downloading anything on Coursera. Not on our in that course. Okay.
Thank you.
Okay. So we have it's been a lot. I know, guys. I know it's a lot. I know it's a lot, and it's new for a lot of us, right? So some new terms. It's kind of hard to wrap our head around it. So far, we talked about thick clients, which is, let's call them everyday run of the mill clients. Then we talked about thin clients, also known as dumb terminals. They pretty much, the only requirement for those is that they need to be able to connect to a network, right? And then now we talked about virtualization workstations. And for these, the main point that I want you guys to take away from this, please write this down, is that virtualization workstations allow you to be able to run multiple operating systems in one physical machine. If you're taking one thing away from today, that's what I need you to take away. Virtualization machines allow you to run multiple operating systems in one physical machine. And then under that, you need to write RAM is the most important requirement for these kind of builds, followed by powerful processors with multiple cores. These are like the bold takeaways that I need you guys to take away from this.
So sorry, DW. What's the first sentence you just said?
All right. So sorry, I have the memory of a goldfish. But so virtualization workstations provide you the opportunity to run multiple operating systems on one physical machine. Right? And we call these instances that we call up, we call them virtual machines. And each one has its own operating system. Okay? And those machines, they all share the resources. Even the host ones. They all share those resources. And the most important requirement is RAM. You need to have a lot of RAM. And the second most important requirement is a powerful CPU with multiple cores. Cynthia, do you have another question, or is your hand still up?
No, sorry, I don't have a question.
Adriel, what's up, bro?
For virtualization with stuff that is kind of let's say when it reaches, like, it's not just on one system. I would say like test out. Think about test out, I guess. If we were talking about being able to do certain things on test out, would that count as they're using? I'm tripping over myself because I'm trying to explain it in a way that gets everything out. I don't know how to explain. How do you process virtualization on a very big scale? How do you do that for more than one system? Or is it like multiple systems on one server and each virtual machine would be?
They have these super rigs. They'll have rigs with tons of RAMs and tons of cores. And then what happens is they divvy up those resources. Like, they take into account what those virtual machines are going to be used for, and they allocate those resources. So depending on what they're being used for, you can have one machine that spins up 100 instances of Windows. It just depends on how much RAM they have, how many cores they have to allocate. It all depends on the actual hardware that you have, and then what you're trying to run those machines to do. So
I get it now. That's
what it depends on, and depending on the depending on the infrastructure or what they're being used for, it could be more than one. It could be that they have five of those servers that do that. It could be that they have 10 of those servers that do. But the thing is that whatever they're using those for, like, they're allocating those resources for. They're building it with that in mind. And when they go up to spin them, they might have like like these instances might be scripted to happen as they're being pulled, right? They might be automated. Like they can have a server with X amount of RAM and X amount of cores, and every time that someone logs in and needs a VM, it'll create one on the spot and it'll load it up, and then once it's loaded up, it'll give you access to it. And then once that machine is no longer needed, it'll kind of like debuild the machine, and those resources will go back into it. But that's a little bit more complicated. I didn't mean to complicate things a little bit more for you.
No,
but just know that these servers, whoever is designing them, they're taking into they need to know how much they have, how much of each resources they have, and what they want those virtual machines to be, and how much they're gonna need. Like they take all that into effect. That's a must.
I understand.
What's up, Bartez?
All right, quick question. It's a little even ahead of this, or maybe even off. But a solid state hard drive, is that called a SSHD or just a SSD?
Solid state hard drive is SSD. So we had a question about that earlier. SSHD is a hybrid. It's like in between solid state and a regular HDD, and it's a little bit cheaper usually.
Yes.
Yeah.
Appreciate you.
You're good. All right. All right. So now we're talking about graphics workstations. So graphic designers mainly fall into computer aid design. Remember these acronyms, guys. These acronyms are going to come up a lot. CAD is computer aided design, and then CAM is computer aided manufacturing. And these are type of workstations. So we usually call them CAD or CAM. And all of them require workstations to be able to use high applications that take a lot of resources, like Photoshop or Auto CAD. And those things usually are going to require high-end, they're going to require a solid state hard drive. So they're going to require fast hard drives. They're going to require maximum RAM because a lot of calculations are being performed. So you need all that extra RAM. And then they need high-end graphic cards with their own memory, processor, and their display adapters. They also need high-quality monitors. Okay, so these are all the requirements for them. I would take a screenshot of this. Okay. So people who design things like, anything that's graphics related, like web design, interface design, things like that. And then manufacturing, also people who like work at places where you build things. Artez, you have another question, or is your hand just still up?
No, I'm good.
All right. What's up, Brianna?
Will this include video games for graphics PC?
No, we haven't gotten there yet.
Oh,
This would be like video game design.
Yes, video game design.
That's what I meant. Sorry.
Yeah.
I meant like
not playing game, but video game design.
Absolutely.
Okay.
Designing them, this will fall in that category.
Okay.
All right. Computer aided design, computer aided manufacturing, CAM and CAD. Okay. Any other question about this right now? These are their requirements. I would definitely take a screenshot of this. All right. Let's see what else we got. Audio editing workstations. So DJs, people who work with sound, who make sounds, who work with music, right? They're editing audio, right? And these kind of workstations are very similar to graphic workstations, but they need high quality audio interfaces. All right. So they have multiple input and output devices for things like microphones, speakers, instruments, recorders, drum machines, beat machines, all these things. They need to have all these different interfaces available to them, right? And they also need high-end audio sound cards. Okay. The next one is video editing workstations. So video editing workstations combine the requirements of audio, and graphics. So when you're thinking about video, because video, most of our video comes with sound, you need high-end sound cards, you need high-end graphic cards, you need a lot of RAM, you need a lot of CPU. Like, these are very powerful workstations. Usually you're also going to need a second monitor, because whatever you're working on over here, as you're running it, you want to see the differences between what you're doing, right? So a lot of people who work with videos and or those kind of things, you'll see them have two distinct monitors, because they're running their editing software on one side and maybe running the video itself or whatever they're seeing, they're running it somewhere else. All right. Okay, so some video editing stations have multiple hard drives set up in RAID for enhanced storage capacity, right? Video takes up a lot of space, so that's why you see this requirement. They might have RAID set up. Okay. This one, like the video editing, kind of, since we learned about the audio and the graphic, it kind of makes sense to put both of those together, right? You guys think so? All right, a home server PC. So as more computing devices move into the home environment, there's more need for a centralized PC to provide multiple servers to all members of the house. Home server PCs mainly supply three functions: media streaming, so streaming video from your other computers. So if you have a lot of home videos, or you uploaded all your DVDs into digital format, you might store them on your home server. File sharing, if you have a lot of files, or you run your business from home, you might also do that. And print sharing, we have like 4 different computers and we have one printer, right? So we share. I have my wife's workstation is set up as our print server. So this is when you see a home server, this is what you use them for: media, file sharing, and print sharing. And remember, a server is a system that serves up services to something else. So it's just something that's allowing something else to get services from it, or resources. So it may be the media, it might be files, it might be allowing you to print something to, with a shared printer. The key word here is centralized. All these services are centralized in one location, and allows all the users to access it. All right, the requirements for a home server are, if the home server is very active, then you need a good amount of RAM and a nice CPU. Because everything is in a network, you probably need a gigabit NIC card. And if you want to have redundancy, if you want your data to be backed up, you probably need a RAID configuration, or at least have some kind of backup capabilities. All right, if you guys got questions, you gotta just raise your hand. I'll be free to answer any of them, or try to answer them. All right, home theater PC, Htpc. A home theater system enables to play music, watch movies and television. An optimal home theater has 5 components. It has a monitor, a TV, or a projector. It has surround sound speakers. It has a stereo receiver. It has a home theater PC, and it has network connectivity. So the requirements for the Htpc are a video card with support for large monitors, usually a HDMI connector, a nice NIC card with a nice speed, usually gigabit is preferred, and sound card that provides 5.1 or 7.1 stereo. And it says a DVD drive here. Some people might not use a DVD anymore, so it might just be the HDMI connector, maybe a display port depending on what kind of video interface you're using. Sorry, I didn't mean to skip. I'm gonna give you guys a chance to screenshot this if you like. Kelly, you got a home theater PC, yeah? Kelly's not there.
DW.
What's up? You gotta speak up, bro. I could barely hear
Nah,
you.
it's because I'm second guessing what I'm thinking. That's why I don't want to speak as
Oh,
if
what's
I'm
up?
confident. I was thinking about the home theater setup here. Wouldn't okay. Stuff like the audio, like audio cards or something like the sound cards, that only enhances the type of sound that you'll hear through whatever type of speakers you have and stuff like that. I was thinking about it having like I guess having a very strong CPU and GPU, because it's like depending on what, well no, it would just be graphics though, because it's like what you want to see rather than
all right, so it depends. So here's it. So it does need a nice sound card because you want to have high quality audio, right? Especially like if you're springing to build a home theater PC, you care about your sound, right? But it doesn't need a high end graphics card for this reason. High end graphic cards are there to perform a lot of calculations, right? To give you to be able to do all those things. What you do need is a video card with the interfaces that you want to use. Like you want to be able to have a video card that has HDMI, that has Thunderbolt, maybe if that's if that's what you're going to use. Those are the main things that you worry about. Like, but you're not springing out for like a 3750 graphics card. You don't need to go spend that much money on it. You know what I mean?
I would say
you need to be able to connect the kind of monitor that you want to use or the projector. You need to be able to interface that with the PC.
That's what I was thinking, because it's like if you had like a certain monitor that you were thinking about housing, like whatever you were,
and you definitely got to make sure that your video card supports that kind of monitor.
Yeah, it's not. I was thinking of it more like, okay, so I'm gonna have the best graphics card, and even though I don't have a 4K monitor, I'm gonna be running this stuff at 4K, because I'm not gonna be able to see it, but it's there.
It's
brag about it.
That's another thing, right? Yo, how many of us have gone to Best Buy and we only wanna? This used to happen to me, right? Didn't happen to me, but it used to happen to my friends. They would go into they were like, oh yo, I'm gonna get a new TV because I just got PS5. Yeah, I'm gonna go get the 8K, and I'm like, and we're there, and the Best Buy rep, obviously they want to sell you whatever they can, right? They want to sell you the best system they can. They're like, oh yeah, this is the best. It has 8K resolution. It has all this. Yo, that PS5, you're not gonna be able to get 8K. Or let's take it back. Let's go like PS3. Like you're not gonna be able to get that high end of it, right? You gotta know what your system is built for. So just because your display monitor or whatever you're using is built for 8K doesn't mean that the graphics card inside of whatever system you're using is going to give you that output. So that's a great point.
That's
I went with my boy when he got the PS4, and the guy was trying to sell him like this 3K TV, and he was like, "Oh yeah, you can hook it up to." I'm like, "Yeah, you can hook it up. It's HDMI, but it's you're not gonna get, that $500 TV over there is gonna be better than that because it's it's a smaller size, so you get less lag throughout it. So he was like, "Wow, you just saved me $2,500." I was like, "You're welcome."
I think he owe you like 1,000.
That's my boy. He's that's my boy. Like I'm his best man. He's godfather to my kids. Like
that's love. That's love, bro.
Yeah. What's up, Caleb?
Yeah, 250.
I will admit though that I do feel like these newer TVs are coming out look super crisp, man. Like you could like reach out and touch it. It's that real. But they're so expensive. Holy moly. Like we're talking like for a medium-sized one, $5K.
Yeah, it's a lot of money. Like I need to badly, when I started the cohort, one of my first questions to Kelly was like, yo, I got these white dots all over my TV. How can I fix that? And he was like, yo, let me get through the lecture and then I'll try to help you out. But basically I had white spots on my monitor, meaning that I got lit pixels. You guys went over the display device yesterday, meaning that those pixels are permanently turned on to white. So no matter, it's just there. Like I can't fix it. And I've been researching TVs for over a year now, and like every time that I'm like, yeah, I'm gonna go for this, I'm like, nah, I'm gonna wait. It's gotten to the point like it's getting even worse. So this Black Friday, I think we're.
I was about to say Black Friday is coming.
I think it's time.
I'm down for that too, because I need to get a few things that I've been slacking on. It's because you can get them cheaper on holidays.
So I have a 55. I have a 55-inch one, and I'm like, I kind of want to go 65 because my stand can hold up to like 70, and I'm like, yo, I want to do but I'm just like, yo, it's a big difference, especially like if you start going towards 8K, like it's almost double for those extra 12 inches, 10 inches.
Yeah, you're right. And then you got to make sure you got those inputs, because if you don't have those inputs, you're not going to get that look.
Yeah, absolutely. So I run everything off of my Xbox. So the new Xbox does provide 4K. So I wouldn't need an 8K because a lot of the games there are still not there. I don't even play my games like that anymore. And but I don't know. I think I'm gonna set my budget at 1,500. See what I can come away with. What's up, Ninja?
So what is Alexa?
Alexa is a virtual
Amazon.
According to Amazon.
This might answer your question.
Alexa, stop.
Alexa, stop.
So, no, I mean, like, is it a virtual machine? Like, you know what I mean?
So Alexa itself is a virtual assistant. It's an algorithm that learns based off all the inputs that go in it and whatever it's programmed to do. Somebody programmed it to be like, hey, if someone asks you about the Yankees, pull this up, or go on Google and pull this information up and read this out. So it's something that someone programmed, and when you give it something to do, it looks in its program for whatever, to see if there's a match for that, and whatever the match comes up, it'll pull something up. But it's a program. It's not a virtual machine. It runs on a virtual machine somewhere in a server somewhere, but Alexa itself it's what we call a virtual assistant, and I think those come in the new test, right? We're gonna have to learn about those, right, Kelly?
Yeah, but is it a
Yes,
thin?
I believe so.
Thin?
I'm sorry, Ume, you need to say that again. I didn't hear you.
Yeah, I'm saying like, is it thin? Like thin? What you said, I forgot. But is it thin machine or thin? What you said, whatever.
It doesn't relate because Alexa is a program built. It's something else. It has nothing to do with this.
Does it have CPU in it?
So Alexa again is the program. So think about Word. Word is a program. Alexa is a program, and it
So
just
the
happens
actual hardware, like you know how you.
If you're talking like the Echo Dots and the
Yes,
Echo,
yes.
yes.
Oh,
they
okay.
do have
So those are not.
processors
That's not
in
Alexa.
them.
Those are the devices.
Yes, the devices. Do they have RAMs and CPUs and everything in it?
Yes.
Wait, isn't
And lots of
aren't
microphones.
those like servers? Like, because you connect your light bulbs, your thermostat, like anything to them, essentially.
Yeah, they get attached through Wi-Fi. It's almost like kind of like a thin client. But when you're speaking of the virtual assistant itself, that could be on your phone, that could be on your computer, that could be in the device. So you're talking about two very distinctly different things.
Yes. So the
you're
actual
speaking specifically of the hardware.
Yes.
Yeah, it's like a little thin client almost.
Thin client.
That's okay.
Yes.
Oh, that's really
And
cool. I
so
like
and then
that.
it's running off of virtual. It's running off of the cloud, right?
Yeah, it's connecting to their servers,
Mm,
and it's using the voice recognition to determine what it is you want information of.
okay. So it's
You
the
can play
C.
games on it and all that kind of stuff. So
Okay, great.
All right, let's move on. Gaming PCs. All right, Brianna, you wanted to read this. Go ahead, read it.
I did.
Yeah, you were asking about it. That means you wanted to learn about it.
Oh, okay. While casual gamers can get by with a thick client, those who take their gaming seriously want a powerful PC ready for every game. Requirements of essential features for a gaming PC are fast multi-core processor, a lot of RAM memory, high-end video card, high definition, and cooling capacity.
Do you have?
That doesn't exclude the liquid cooling, right? It can just be fans and stuff, right?
I mean, you just gotta. You definitely. It could be liquid. It could be fans. But the point is that you want it. You want your gaming PCs to have the right amount of cooling. You definitely. You have a processor that is that if you really take it seriously, you're probably overclocking your processor. So there's a lot of heat. You're probably overclocking your graphics card. There's extra heat there. So you need to keep it cool, right? Yeah.
Can you remind me what overclocking is again?
Overclocking. So when you buy a component like a processor or a GPU, it comes set at a certain its maximum speed that is working, right? How powerful it is. You can go into your settings and make it above that because the manufacturer will have it set at a specific thing. It might be like 90% of its actual capabilities, but then you can go in and overclock it to work even faster. But at that time, you're risking it getting hotter, and you're also risking a shorter lifespan because you're making it do more work, right? So that's what overclocking is. So essentially, you're enabling your hardware to work at a higher rate.
Okay,
So
then it's supposed to, right?
Yeah, then it's manufacturer intended it to be. Yes.
Okay.
Yes. So these are the
It also
requirements for
avoids
your
warranty.
Yes, it does. Although so here's the thing. So some graphics cards will come in with a feature that is called that is like it's built into it. So if it comes in with that feature, you won't be voiding it.
Yeah,
because
the turbo is okay, but if you
right, so
get
yeah,
into the thing,
so like my GeoForce has a turbo boost on it, which is essentially overclocking it, and because it's built for that, I don't void my warranty, even though my warranty is expired now. But yeah, so this is going to come up a lot for gaming PC. So multi-core processor, lots of RAM, high-end video card, high definition sound, cooling capacity. A good gaming PC is not cheap, especially post-pandemic.
Yeah, prices went up during the pandemic.
Yes, there was for those of you guys who didn't know, there was a chip shortage, and components that were usually $200 started selling for thousands, $1,500, like up to 8 times, 10 times more than they were worth.
Still is a chip shortage.
Yes. And these chip shortages affected everything from gaming PCs to your cars. If you guys realize, I don't know if you guys went shopping for cars, but because of the chip shortage, there was a big uptick in new cars.
It's everything.
And used cars too. Yes, everything went up. Yeah, that's true.
Well, no, what I'm saying is you have chips in everything now. You have chips in dishwashers, toasters, washing machines, dryers, ovens. I mean, it's everything.
I toast my bread on a skillet. I don't think my skillet has a chip yet.
Toaster.
Well, DW is a little more of a Luddite. I respect that. All right, but
it's also why my toast is always burnt.
There you go. So George has his hand up. I guess he's asking why I crossed out lots of RAM.
Yeah, it's because you can use things like GeForce and Steam Link to just stream something from another computer. You don't really need that much RAM.
Nope, that's actually not it. And they will even state this on the exam. The reason why they say you don't need a lot of RAM, even though this is exam versus reality. In reality, you're probably going to want some RAM, but with regards to the exam, their argument is your GPU or your video card that you're putting in has RAM built into it, and primarily the graphics processing and the heavy lifting is going to come from that video processor, not the RAM on your motherboard. So if you are limited in resources, Because this is where it comes down to, is like when you have to build out machines, they're assuming limited resources. They're not assuming that you have a blank check where you can go out and buy whatever the heck you want. They're assuming I have to choose between getting a high-end video card or a whole bunch of RAM. So you would go for the video card before you would go for the RAM.
All right.
So yeah, crypto mining ate up a lot of the GPUs for a long time, but with Ethereum switching over to proof of stake, that should ease a ton of pressure on that. So, sorry.
No, you're good. That was a good point. All right. So we have an example of a nice little gaming PC here. So this here, this GeoForce GTX is the graphics card. So Madison, remember when you were asking me about riser cards? So remember how I told you we use it for when we have limited space? You see this case is big, right? So you don't need a riser card here. But let's say you wanted a smaller case, because let's be honest, nobody wants a huge tower. You know, not everyone wants that. But you still might want a nice graphics card. Then you would use a riser card, and what it does is it changes the orientation and allows you to be able to mount that card on there. It changes the way it looks. So instead of it just being like flat out like that, there'll be like the little adapter here, and then it'll like either go up to the side, right? And then that way you can mount the card on that way. I'll look for an example after this to show you a riser card. But riser cards are usually used in smaller form factors. Yeah. So I'm trying to see the fans here. I'm trying to see if I see the fans. So we have a fan right here, and we have this is the power supply down here. I don't see anything like high end. There is another fan right on top of the processor there. And then some of the graphics cards, like I know my graphics card has fans built directly on it, and it'll push air out through that, and it'll cool like that. But who had a question? Was that Artez? Was that you?
Yes. So the riser, what she was asking about, is that something like when you go to build your computer and you place in your motherboard in, sometimes they have these risers built into the tower or to the case? It's just to lift it up off of something, or is it to serve
It's inside. So it's inside. Let me pull up
It could be one of two things, like DW was talking about, where it changes the orientation of it so you can save a little space. Or if you don't have enough PCI slots, you can use a riser card, almost like a hub for PCIEs. So you put one in, and it'll allow you to add 2 or 3 more cards if you need to.
But isn't that at the expense of performance when you do
Yes,
that?
it absolutely is. So you would put your lower, like you wouldn't put your graphics card in a multi-port slot. You would put that in its own primary.
Yeah. After this,
Cool.
after the lecture, I'll pull up a picture of a riser card so that we have a better understanding of it. Because it is good and it is relevant to the exam. They do ask questions about that. But yeah. All right, so here we have examples. Is this new? I don't remember this from last time. Did you just add this, Kelly? No,
that's been there. It's old. It's really old. Like it's a couple years.
All right, so here we got a Windows 10. It has a i7 processor. It has a GTX 1070.
I was just trying to give examples of one.
8 gigabytes of RAM built into it. Then you have 16 gigabytes of RAM on the thing. You have 120 gigabytes of a SATA SSD. And then it has another 2 terabyte SATA. Ooh, damn. All right, so here we see some of those things, right? It has a decent amount of RAM. It has a nice graphics card. If we go on to the other one, this one's for VR. I've never played with VR. Have you guys played with VR? Kelly likes VR. So this one has a slightly better graphics card. Everything else is pretty much the same. The SSD is slightly higher. All right, then we get over to this really inexpensive one. It has, so also a thing to remember is usually Intel PCs that have an Intel chip are more expensive. Like AMD usually is a lot more reasonable price. So you'll see a lot of gamers like go for a really high-end AMD processor sometimes because it's a better price point, right? And then this one has half as much RAM, and it also has half the amount of storage. Right? Notice that none of these come with a monitor. Usually, you got to purchase the monitor separately. And then you have the high-end one over here. The graphics card is almost the same, but it has a little bit more built-in RAM, right? And then it has 250 gigabyte M2 SATA. So when we learned about drives, we learned about M2. It's a faster connection, so it's even faster than your regular SSD. And then it has also a 2 terabyte hard drive. So these are just to show you how much they could vary depending on what you want them to be able to do. And like Kelly said at the beginning of the cohort, like for some really nice gaming PCs, you'll have like see-through cases. And depending on what you got in there, people show them off as art. They might have a lot of lights and stuff like that. And, that's something that some people do as well. So here's an example of video cards. So this is a NVIDIA one here. And then you have an AMD Radeon. Okay, you don't just so you could take a mental image of what they might look like. So one thing I would say, who could tell me what interface this is? Like, where am I sliding this into?
PCIe?
PCI 16 because it has the hook on it.
Yes, exactly. Thank you. All right. And then depending on the video card, you see how the back, so this is where all the connections go. So this looks like it has a display port and like 3 HDMI ports. Yeah. And then it has the vents so it could cool off in the back. All right. All right, so let's take a screenshot of this. So this has all the workstations that we spoke about. And then the things that are checkmarked are the things that you need to worry about when building them. So you see, so it's confused. So for gaming, it's saying that the things that you need to worry about most are the video card, its storage, and its audio. Right? You still, like, I definitely would care about the processor and the RAM, right? But for the exam, these are the things that they want you to worry about. Like,
and their argument is the processing power is coming from the video card, so it's not as important.
Because the video card is its own processing unit. That's exactly. What's up, Ninja?
Oh, this just answered my question. Sorry.
Yeah.
This.
So this slide, definitely screenshot it. This is what the exam will definitely ask you about. What the most important things are, and then just start, go over it when you get a chance. Try to we didn't talk about NAS. Did I skip that over? I didn't see the slide for NAS actually.
I think NAS is the last slide, right?
Is it? That's okay. Thank you.
Yeah, it's the last slide.
It somehow got out of order.
Yeah, because I'm like, wait, NAS is not here. Okay, Thin Client needs network connectivity. Okay, it's not on here, but remember that. That's what it needs. All right. So here it says that your thick client has to be able to run its basic OS requirements. So whatever that OS is that you're running on that thick client, if it's Windows, if it's a 64-bit version of Windows, it needs 2 gigabytes of RAM for Windows 10 or later, or Windows 8, 7 or later. It needs a processor. It needs a keyboard and mouse, all that stuff. So, and then, but for thin client, its main requirement is network capabilities, because I don't, for some reason, network isn't on. All right, you guys got a screenshot of this? Can I go on? All right, I'm going on. Let's check it out. Okay, it was optional apparently, Kelly. I don't know how it's optional. Network attached storage devices. So Nas, for all my Queens or New York people, we're not talking about Queen's son, even though he's one of my favorite rappers. Right? We're talking about network attached storage devices. And
Whose world is
if you want to make your files available on the network to all connected device, you probably need a NAS, which is a mini server. It has its own CPU and RAM, but they don't have a full operating system. They're usually cheap. They're very easy to configure through an interface. And since all the other services are being provided through the network, it has two main things. Being able to have to share on the network, so it needs a gigabit Ethernet NIC card, right? And it needs to have a lot of storage devices because you're storing your things on there. You want your files to be here, so you need a lot of storage, and then you need your network card to be able to communicate over the network. All right, network attached storage. This pops up a lot. Definitely a lot. All right. So before we go on to the next slide, well, maybe we should go on to the next slide. All right. So let's just recap a little bit about all the different ones that we learned. All right. Volunteer to talk about one of them. Volunteer. One of the configurations that we spoke about today. Go ahead, A.
A thin client.
Thin client. All right, what's up? Tell me about thin clients.
A thin client is basically.
Are they skinny?
I mean,
they could be. All right.
It could be, but
right,
if we're
not trying to body shame the PCs here.
No, we don't form factor shame out here. Yo, the chat was hilarious. You need to see that.
Oh, I'm sorry. I didn't have my chat up. I usually do today. I'm sorry,
guys. A thin client is when we are using a device to work out a specific task that would be done through something that usually is interacted with, like from person to person, like a kiosk or a point of sale system.
Ooh, I like your terminology. Your terminology is getting better and better. I like it. Keep going.
So you would use that as a means to have information, or not necessarily information stored, but information sent back instead of information taken out. So it would be something that you can use, and it's mobile for matter of speaking, I can say.
Some of them can be mobile, but what's the main attractor? Like what do I definitely need for a thin client? What is it? It's an absolute must.
You need network interface.
There you go. You
need a very good network card.
All right, bonus question. Is a thin client a genius? Is it kind of smart? Is it like all right, or is it dumb? Like what is it?
It's definitely dumb.
We call it a dumb terminal.
I
like how you brought up kiosk. So kiosk, point of sales, survey machines, these kind of things. They're usually called thin clients, right? They have the bare minimum to connect to the network. All right. So then I saw someone else would like another configuration. I saw Christine's hand. You still want to go, Christine? Or do you change your mind?
Can you guys hear me?
We can hear you. How are you today? Good afternoon.
I'm okay. Good morning. Good afternoon. All the above.
It's now 12 p.m. So good afternoon.
Sorry, in the middle of an audit. Okay, so I will take a virtual workstation, which is not a physical PC. Enables you to run more than one OS at the same time on multiple PCs. Gives you more RAM and operating system functionality. It It's usually used for testing purposes. That's pretty much what I got.
All right. So I love the enthusiasm. You got some of the points correct. I'm just gonna add and correct a little bit. Is that okay with you, Christine? I'm just gonna elaborate just a little bit on it. So your virtual workstation enables you to run multiple operating systems, which we call virtual machines, on one physical PC, right? And then those virtual machines can be distributed out over the network or over the internet to other systems. But essentially, what I want you guys to think about is that these virtual machines exist inside of one physical thing, right? So there's one physical machine, and it's housing however many VMs you're spinning up. It could be two. It could, it's at least two, right? Because there's one and at least another one. So it's at least two to however many that you can.
That was my question earlier to you. Is Citrix considered a VM or virtual workstation? Citrix, a Citrix environment.
I'm sorry, I'm not familiar with Citrix. Is anyone familiar with Citrix, Kelly?
I don't think Citrix is a VM. I think that is a VPN to get you into your local environment.
I'm sorry. What do you use it for?
What about Zen Desktop? Would that be considered a thin client or a VM?
Zendesk is a ticketing system, I assume, isn't it?
No.
Yeah.
It's actually a physical, it's like a little machine.
Okay. I thought we were talking about is that the Zendesk ticketing system?
Okay. So
I would have to look at that, Christine.
Let me go over it one more quick time. All right, Christine? Because I know it was a tough topic for all of us. So let me just try it again. So a virtualization desktop allows you to run multiple operating systems or virtual machines in one physical system. Okay. And then the most important things for this that you need to be able to build your virtualization workstation is a lot of RAM, processors with high powerful processors with multiple cores. Right, those are the two most important things. And then I don't want to confuse you guys too much, but that's kind of the gist of it. Like these machines are running in one physical machine, but there's multiple instances of them, and it could be, depending on how much hardware you have, it'll affect how you could distribute that. But thank you so much for your participation, Christine. You had a lot of it down pat. I just want to make sure that you understand it correctly, so that way I gave you the correct information.
Gotcha. Thank you.
Right. Thank you. Who wants to try another one? Yeah, what's up, Steve? Let's go.
Okay. Are you asking a question, or do you want me to just add to?
No, it's just so we talked about thin clients and we talked about virtualization ones. So what's another build that we talked about?
Thick client.
A thick client. Boy, that PC is thick.
Exactly.
So what makes a thick client thick?
I just can't. So basically, from what I remember, oh man, it accomplishes like a lot of tasks, like for office space or even at home. Like it's like multi-purpose in a sense.
Multi-purpose, run of the mill, get the basics out. Like it runs the basics for the operating system.
Yeah.
You need to be able to run Windows. You have a thick client is a computer that can run Windows for you, pretty much.
Right.
You can do all your basic stuff on it. Yes.
Office productivity, all that good stuff. Yeah.
Exactly. Yeah, you might even be able to run some basic games on it.
Right.
Yeah. All right. Cool. All right, Galen, you want to take a shot at one of these?
Yeah. A video editing workstation.
All right, video editing workstation. What do you need for a video editing workstation?
Um, well, let me- okay, so you need a very powerful CPU. You need a strong CPU. Paired with as much RAM as you could possibly pair it with. Much RAM as possible. They have multiple hard drives.
Yes.
RAID.
Yes. All right.
For more storage.
All right.
And,
what else?
And more and better performance.
Yeah. So think about for video editing. What do you need? What kind of processor do you need for that?
Video editing.
Yeah. Wait. Were you describing the video or the graphics one? I'm sorry. You were describing a video editing workstation, right?
Yeah.
All right. So there's one more component there that I wanna hear, and it's gotta, like, how are you doing the work? What do you need to actually do the work? It's all right. I'll give you a hint. All right, I'll help you out with the last one because you did such a great job. So you definitely need 2 monitors, or you want to have.
Yeah, I was getting ready to get to that. That was like the second part. That was the last part of my movie.
Yeah, I wasn't doubting you, bro. I just gave you a little push.
Not bad job.
You were in the air, and I gave you the alley, and you slammed it home.
I kind of like spazzed and threw it.
Let's go.
Nah, listen, bro. Kobe scored 81, but some people still had assists. So you were on your way. You did a great job. So thank you.
Thanks, man. Thanks, y'all.
All right. So we got the thin, we got the thick, we got the virtualization, we got the video editing. Artez, what do you want to talk about, Artez?
I'm gonna spit a verse from Nas. Is that okay? Hold on, little bro. Nah, I'm gonna do the Nas, the network attached storage.
Oh man, I got excited. I thought he was talking about the real Nas. My bad.
In here.
I'm sorry, I'm in my bathroom. This is my second workstation, so I might be echoey. But for the Nas is to make all your files available on the network and all connected devices. It's a mini server that has its own RAM and CPU. Yes. But it does not have an OS. It doesn't have no operating system.
Yeah, it has a very minimal OS, right? That's good.
Minimal.
Yeah.
All right. It's cheap. It's inexpensive.
It's cheap to set up. What is this most important thing? Come on, you're there, bro. You're up. You gathered with 2 feet. You're about to windmill. You just got to slam it home now.
It's easy to configure through an interface.
You need the interface, right? What kind of interface? What is that you need to connect to?
The NIC card.
The network. There you go, bro. You got it. That's it, man. You got it.
The network or the NIC card.
You went to the dunk contest and you got 50 out of 50 points, man.
Holy. Hold on. Let me just make sure. You said network or the NIC card?
Yeah. So the NIC card is your network interface.
Ethernet. Right. Yes. Oh, facts.
Yeah.
Facts.
You need a good one because you want your network card is what is going to give you those good speeds, right? So you probably need a gigabit one.
Yeah, gigabit Ethernet card. Yeah, so I just put my arm in the rim.
That card is probably the biggest thing, and you need a lot of storage on it because you're trying to store all these things, right? So you need somewhere to store it. But yo, great job.
Media streaming and file sharing, yes.
You can set it up for all those things, of course. Good job. All right. So we got Nas down. Sorry, Jay. Sorry, Jay-Z. Who's next? Oh, I don't want to pick on someone. Come on, guys. Come on, gamers. Who's gonna describe the gaming PC for me?
I just got back. I don't know what we're talking about.
No, I'm just asking people to describe another workstation. You did one already, so you can't go again.
I'll do it. For the game.
Oh, there you go, my boy Don. Don the Don.
You need a fast multi-core processor, a lot of RAM, a good sound card, sufficient cooling.
Yes.
And a good graphics card.
All right. So you in real life, for real life, you just described a great gaming PC. What about for the test? What do they want for the test?
For the test,
What are the
they
three
say
things?
that the RAM should be integrated into the video card or graphics card.
Yes, so your graphics card will be integrated in there, so they don't account for that. So there's three big things that they're going to ask in the test for the gaming one. So one is the graphics card. What's the other one?
Processor.
What?
The processor.
So
you hear
the
me?
graphic, so they take away the processing and the RAM because they're like, yo, that goes with your GPU. So the big thing is the high quality GPU,
Monitor.
right? No, so the high quality GPU. So you have great video and then or great graphics, and what else? Yo, you want to hear those footsteps? So what do you need?
Surround sound.
A good sound card, yes.
Yeah.
Good sound cards, right? So that's two, and then there's one last thing. That GPU is nice, is working very fast, is working very hard, is getting really hot.
Cooling.
So you described it perfectly for real life. Those are the 5 things in real life. For the test, they're gonna ask. You need to know that it's the really good graphics card, a high end graphics card, high end audio card, and good cooling. Well, great job, Don.
Thank you.
All right, cool. So that's another one down. Who wants to take a crack at something else? Well, I think we got like 3 more to go.
Good video.
Home video, a home theater PC. Is that the one you're talking about? The with?
No, just for gaming, just good video quality.
So that's the one that Donald just did right now. Was the gaming PC?
Yes. For home,
Yeah.
I think it needs for home video, for home setup, we need a processor with good sound quality and video, and also it needs a good networking system.
Yes. So so you're describing the home server or the home theater PC? Which one were you describing for us?
I think for home server.
The home server. So yeah, so depending on what you are trying to divvy up, it could be that you're divvying up your videos or something like that, or your media. So you might want high end or a decent video card. You want definitely a decent processor, depending on how many different users are connecting to that home server. You need network connectivity, so that was really good. And you also need the storage, right? So you want to be able to store all those things, and you might want backup in like a RAID or something like that. So yeah, those were pretty good. Good job there, David. All right. Galen, do you have another, or you still just have your hand up? I think you just got your hand up. Babacar, you wanted to say something?
Yeah, I was just adding on to what he said. I said
What
you
did you
also
add?
have a sufficient memory to your home
Right.
server.
You should have definitely enough RAM. Yeah, that's true. Yes. All right. So we talked about the home server. We talked about gaming. We talked about virtualization, thin, thick, and we talked about video editing. All right. So we got 2 more. We're gonna group one of them together. So computer aided design and computer aided manufacturing. We need. I'm gonna do this one for you guys. Those need a lot of processing power. They need high end graphics cards, right? And they usually need a high end display because, especially for the graphics, like if you're designing a video game or you're designing something that needs to be visually perfect, those colors need to match. So you need high end displays for that.
Sorry. That was the
Yes.
CAD. Was that the CAD?
CAD, computer aided design, and then CAM, computer aided manufacturing. Yeah, you also need very fast hard drives.
Hey, for the graphics PC, is that normally used in like visual effects too for movies?
Yes.
Okay.
Yeah. Yes. All right. So we'll add to those things. We'll also all right. So we talked about the video editing. So what about for like sound editing? What's like the most important thing for sound editing? What do we need? What do you
Sound
think?
card.
Yeah, a very nice sound card, right? We need to be able to connect all those different output and output devices, our instruments, all those things, right?
Yes.
All right.
A lot of RAM.
Yeah, a lot of RAM to do
A
those
lot of
processes.
storage.
Read.
All right. Did we miss one? I think we spoke about all of them, right? CAD, CAM, video editing, audio editing, graphics. We even got NAS in there. I think, is there anything that we missed? Anything we want to go over real quick? I think we're good. Please speak up. I think we can.
I have one thing.
Yeah, what's up?
I just want to go over the requirements for CAD and CAM. I have just fast hard drives. Or do I have that note already? I see you going back.
Yeah, isn't it under graphics?
I do have that note.
No, CAD.
CAD is under graphic workstation.
Yeah, here we go. So CAD and CAM.
Yes.
So your requirements. So here are your requirements. So yeah, so fast hard drives, so solid state hard drives, a lot of RAM, high-end graphic cards, and high quality monitors. Yeah.
All right, thank you.
So yeah, and this applies to both CAD and CAM. Okay. And you see how this is set up? Look at all the monitors they got. Like they got a lot of stuff going on there.
Is computer aided manufacturing just Photoshop, or does that go with like
No,
3D
it could
printing
be.
too?
So computer aided manufacturing are for like think architecture, think like machines, think like engineering, like those kind of things. Like these are applications that do a lot of calculations, that do 3D rendering, things like that.
It would be like creating products that need to be
Right,
like virtualized.
Yes. Yeah, that's kind of what it is there. Yeah. Okay, guys. Well, we went over this again. This is I don't expect you guys to get all of it today, but at least we have a better understanding of the different type of workstations that are in the industry and how we can go about building these kind of different workstations and what the requirements are. So we'll talk about this more as we go through the cohort. But again, I want to thank you guys for participating. You guys asked a lot of good questions. You guys were into it. You were patient. And I'm very happy with the participation today. So great job, guys. Please go. Okay, someone's asking me to go to audio real quick. So the audio editing workstations are similar to the graphic workstation, but you need a high quality audio interface, powerful speakers, and multiple input and output connectors. All right. All right, Kelly, I think you're back on.